Recently, there was a breakdown in the water cooling system. We have a workman down at the pump preparing to disassemble the bearing and inspect to see if there was any damage. So let's see how it's done. Before beginning any work, the worker has already familiarized himself with the manufacturer's instructions and checked to make sure that the equipment has been properly tagged out. In addition to that, he's cleaned the outside of the bearing housing. He's also match-marked all flange mating surfaces to be sure that the bearing can be properly reassembled. He uses a crisscross pattern to loosen the bolts for the housing end cover. As you'll recall, this is done to minimize the possibility of the flange mating surfaces being warped or cracked during disassembly. In this case, a specific loosening sequence was given in the manufacturer's instructions. If a sequence isn't given, you should use a crisscross pattern to be sure the stress on the mating surfaces is relieved evenly. So he continues using the specified pattern until all the bolts have been loosened. Once the bolts are loose, they're removed by hand. Then they're placed in a plastic bag for use later on. With the bolts out, the end cover and gasket are removed and set aside. Next, he removes the worm gear that's installed on the end of the shaft. This is for an oil pump drive, which is not used on this particular pump. He first removes the set screw. As he removes it, he feels for any resistance. Resistance would indicate that the threads had been damaged. He continues loosening until the set screw comes out of the shaft. Once the set screw is out of the way, the worm gear comes off the shaft. While removing the worm gear, he's careful to pull straight. If he didn't, he could scratch the shaft or the gear. Once it's been removed, he places it in a plastic bag to protect it. It'll be installed later on when the bearing is put back together. After that, the key is taken out of the keyway. With these parts out of the way, he's ready to check the end play or thrust travel of the shaft. This procedure is often called checking the thrust. It's a way of measuring the travel of the shaft, or indirectly, the oil clearance of the thrust bearing. In order to check the thrust, he uses a dial indicator with a magnetic base. To set up the dial indicator, he places the magnetic base on the outer portion of the housing. Then, he positions the dial indicator button against the end of the shaft. While doing this, he's very careful to make sure that the button is positioned correctly on the end of the shaft. In other words, it has to be positioned squarely. If it isn't, a false reading can result. While the worker was setting up the dial indicator, his helper has been installing a collar on the pump shaft adjacent to the coupling. This collar is used so he can safely pry the shaft back and forth. The design of this particular coupling is such that the outer hub can float back and forth. The helper places wooden wedges between the coupling hub and the bearing housing to move the hub in one direction and then hold it in position. This is because he will be prying against the coupling hub when he moves the shaft in one direction. So he also places a piece of wood against the coupling. At this point, his preparations are complete, and he's ready to move the shaft so the thrust travel can be checked. When he receives the workman's signal, he uses a pry bar to move the shaft as far as possible in one direction. The workman adjusts the dial indicator to read 0. Then he signals his helper to move the shaft in the other direction. The helper carefully uses his pry bar to move the shaft, this time as far as possible in the opposite direction. Again, he's placed a piece of wood under the pry bar to protect the pump. The reading on the dial indicator represents the total travel of the thrust bearing. Then the workman signals his helper to move the shaft back again. This move allows the workman to verify that the indicator has returned to 0 and that he has obtained a true reading. Then he records the reading to allow a comparison with manufacturer's specifications. Next, the workman carefully puts away his dial indicator so it won't be damaged. In the next segment, we'll see the remaining steps in disassembling this bearing. But for now, let's take a break. Before the break, the worker had just checked the thrust travel of the pump shaft. He found it to be within the manufacturer's specifications, so he's ready to continue the disassembly work. Let's see how that's done. To disassemble the bearing, he has to remove the top cover from the bearing housing. This is again a flange mating surface. So when loosening the nuts, the worker uses a crisscross pattern. As we said, this is done in order to protect the flange mating surfaces so that they'll not become warped or cracked from uneven stresses. So he continues using the crisscross pattern until all the nuts have been loosened. With the nuts loosened, they're then removed by hand. Next, they are placed in a plastic bag with a tag to identify them for use later on. Then a lifting eye is placed in the top cover to prepare it for removal from the bearing housing, and a chain hoist is attached. With the upper part of the bearing housing prepared for removal, the worker then uses the chain hoist to lift it away from the lower housing. The hoist is used to prevent the cover from slipping or shifting as it's being removed, possibly damaging the studs. Throughout the lift, the worker checks the alignment of the chain fall to make sure that the top cover comes straight off the studs. If it didn't come straight up, thread damage could result. When the cover is completely clear of the studs, it is removed from the hook. The workman and his helper carefully lift the cover, using their legs to lift the load rather than their backs. The cover is then placed out of the way on cribbing for cleaning and inspection later on. At this point, the bearing itself is exposed. Before he begins removing the top half of the bearing shells, he removes the gasket from the flange mating surfaces. This is a little bit different from the arrangement that you saw on the plain journal bearing in tape 1. This bearing housing uses a gasket. You may or may not find a gasket when you're disassembling bearing housings. Gaskets should never be reused, so this one has to be removed and disposed of. He uses a removal tool in order to loosen the gasket from the lower portion of the housing flange. As he does this, he's very careful not to scratch the metal mating surface. He keeps the surface of the knife parallel to the mating surface. And he works slowly and carefully so that the knife doesn't accidentally slip and scratch that mating surface. Once the gasket has come away, he lifts it off the mating surface and sets it aside. Then he does the same thing with the other half of the flange gasket. Once again, he works slowly and carefully to avoid damage. Once both gaskets have been removed, they're tied together and kept for use as patterns for cutting new gaskets later on. With the gaskets out of the way, he's ready to remove the top half of the bearing shell from the bottom half. In order to do this, he first removes 2 dowel pins at opposite corners of the bearing shells. These pins are essentially the same as those seen on the plain sleeve bearing in tape 1. To remove the first pin, he uses a wrench to run down the nut in order to withdraw the pin from the shells. He continues using the wrench until the dowel pin can be removed by hand, and he places it in a plastic bag. He then repeats this process with the second dowel pin. The top half of the bearing shell is connected to the bottom half by 2 bolts at opposite corners. These, of course, have to be removed in order to take off the top shell. So once again, he loosens the bolts with the wrench. The important thing to remember at this point is to work carefully. The bearing shells are exposed, so dropping a tool or letting it slip could damage the shells. Once the bolts are loose, he removes them by hand and sets them aside. Then the upper half of the bearing shell is lifted out of the way to expose the bearing journal and the tilting pad oil film thrust bearing. The upper half of the bearing shell is set aside for inspection later on. Before he can remove the bottom half of the bearing shell, there's some more preparation work that he has to do. What he has to do is raise the shaft of the pump slightly so that its weight is removed from the lower shell. Since he's going to be working overhead and he doesn't want any dirt dropping onto the exposed bearing journal or into the housing, he places a cover over the open bearing. You'll recall we saw the shaft raised in tape 1 in order to remove the lower shell of a plain journal bearing. The shaft rests against the lower shell when it's not moving. So in order to easily remove the bottom shell, it's necessary to raise the shaft a very slight distance to relieve pressure on the shell. In this case, he uses a chain hoist and a wire rope sling in order to raise the shaft. There are several methods that can be used. We saw a different one in tape 1. Generally, the method used is based on the access to the shaft and the construction of the piece of equipment that you're working on. In this case, he's not able to use a wooden block with wedges because there's no place to install them. So this method of raising the shaft with a chain hoist has to be used. But he's very careful not to put the wire rope sling on any machined surfaces. Once the lifting equipment is installed and connected, he takes a strain on the hoist to raise the shaft. Finally, of course, the protective cover is removed. With the shaft raised slightly, he then uses a brass pin and a hammer to begin rotating the bottom half of the journal bearing shell out of the housing. After it's been broken loose in this way, he places a metal pin in one of the oil drain holes to completely turn it around. After the shell has been rotated completely so it is on the top of the journal, it can then be lifted away, taking care not to damage the exposed bearing journal or the thrust bearing. Once the lower half of the journal bearing shell has been removed, it's set aside with the upper half for inspection later on. At this point, the shoes for the thrust bearing and the retainers are loose on the shaft. He has to make sure that they won't slip accidentally during the removal process because one of the shoes could be dropped and damaged. So he uses a parallel clamp to hold the entire assembly in position during the removal process. While doing this, he doesn't apply too much pressure, just enough to hold everything in position. Once the clamp is installed, he then begins removing the set screws for the thrust collar retainer on the end of the shaft. He removes both set screws and safely stores them. Then he uses a spanner wrench to loosen the retainer from the shaft. It's threaded onto the shaft to hold the thrust collar in the correct position. Once the retainer has been loosened, he then unthreads it very carefully, making sure that he supports it as he unthreads it because he doesn't want to damage any threads on the retainer or on the shaft. And that's easy to do if you're not careful. So he takes the time to do it right. Once the retainer is off the shaft, he places it in the bag with the set screws and then sets the bag aside for use later on. The thrust collar assembly with the shoes and retainers clamped to it can then be removed from the shaft. As he removes the thrust bearing assembly, he's very careful not to jar anything because he doesn't want to cause any damage to the bearing surfaces, the thrust collar, or the shaft. So he continues pulling the thrust bearing assembly off the shaft until it's clear. Then he sets it aside on the table. The thrust collar is held in position with a key, and he's going to want to look at that key a little bit more closely later on. So it's removed at this point. There's also a set of shims that are used to position the thrust collar on the shaft. These shims establish the correct position of the rotating element of the pump. He removes the shims from the shaft. They must be handled carefully so they don't become bent or damaged. Once the shims have been removed, they're tied together. It's very important that he keep track of these shims. If they're not reinstalled as they should be, clearances within the pump will be affected. So he carefully ties them together and then places them in a bag with the other thrust-bearing parts. At this point, all the bearing parts have been removed from the pump, so he places a cover over the shaft in order to prevent foreign material from falling on the exposed journal or the bearing housing while he works on the bearing parts. So far, we've seen how a tilting pad oil film thrust bearing is disassembled and prepared for inspection. But we still have to see how the bearing parts are actually inspected. Before that, why don't you review this material with your instructor? Before the break, the worker had just completed the removal of a tilting pad oil film thrust bearing. In the meantime, he's done some very important work. He's cleaned all the bearing parts and made an initial visual inspection for any obvious signs of damage. And he's also inspected the journal bearing that he's just disassembled. The methods he used are the same ones you saw in tape 1. In this case, he found no damage to the journal bearing components. He's ready to begin inspecting the thrust bearing components. So let's see how that's done. At this point, the entire thrust bearing assembly is still clamped together. Before he takes it apart, he has to match mark the various parts so that the entire assembly can be put back together in the proper manner. What he does is place marks on the shoe retainers, those outer rings, numbering each position on each retainer so that he'll be able to match the shoes to the retainers during reassembly. At this point, he doesn't mark the shoes. He only marks the retainers, and he scribes a mark on each retainer adjacent to each shoe. The reason he's scribing is so that the marks can't be accidentally removed. So he continues placing scribe marks on the retainers until each position on each retainer has been numbered. The next thing he does is number the shoes so that they can be matched with their positions on the retainers. In this case, he uses paint markers to place a mark on each individual shoe. He doesn't use a scribe here because he doesn't want to take a chance on scratching the babbitt material on the bearing surface of the shoes. He uses two different colors of marking paint. The reason he does this is so he can keep track of which shoes go on the inboard side and which shoes go on the outboard side of the thrust collar. This is so that they can be matched with their correct positions on the retainers. He continues this entire process until all of the shoes have been numbered. With all the parts match marked, he's ready to begin taking the thrust assembly apart. So the clamp is removed, then the inboard and outboard retainer rings with their shoes are removed from the thrust collar. He's very careful not to jar any of the bearing components as they're removed. You may find that when you do this, some of the shoes will stick to the thrust collar as two did here. This isn't unusual, and in fact it should be expected because the thrust collar has a film of oil on it. Film of oil will cause those shoes to stick. If they do stick, it's necessary to slide them off the face of the thrust collar, but be careful. Don't let them drop. Once he's finished removing the outboard retainer and shoes, he then removes the inboard retainer and shoes from the thrust collar in much the same way. The next thing he does is perform a contact check to see if the shoes have been damaged by the problem with the cooling water system. But to do this, he has to remove all oil film from the shoes and the thrust collar. He uses a lint-free rag to wipe the thrust collar. He then wipes the face of each of the bearing shoes with a lint-free cloth until all oily film has been removed from the bearing surfaces. Once all the shoes have been wiped, they are ready for the contact check. But he still has to prepare the thrust collar. He uses blue dye compound in order to check contact between the shoes and the thrust collar. It's very important when doing this that not too much or too little blue dye compound is used. This can cause a false reading. He applies a small amount to one face of the thrust collar. Then he spreads it with his finger to obtain a thin, uniform coating. This often takes a while, but it's important to make sure that you have a thin, uniform coating. If too much dye is used, you can get a false reading. A shoe that doesn't have enough contact surface will look good. If the coating is too thin, or if it isn't uniform, you can also get a false reading. In this case, a good shoe could look like it had high spots, because the coating would be uneven. In either case, the results of the inspection wouldn't be valid. So if you take the time to spread the dye correctly, you'll get accurate results. And this worker is doing just that because he wants to get an accurate check. So he keeps spreading until a thin, uniform coating is obtained. Then he sets the collar into position to check contact between the outboard bearing shoes and their mating surface on the thrust collar, and lifts the outboard retainer ring with the shoes in their proper positions against the face of the thrust collar. Then he rotates the ring slightly to get good contact between the thrust collar and the shoes. Once he's made the proper contact, he then lowers the retainer ring with its shoes away from the thrust collar and inspects the dye pattern on the surface of the shoes. With this set of shoes, he finds that the contact is acceptable. In other words, the dye pattern on each shoe shows complete contact. The next thing he has to do is check the inboard set of shoes. So he applies blue dye compound to the other surface of the thrust collar. Then he spreads it carefully to make sure that a thin, uniform coating is obtained. In this case, he places the collar on the shoes. The thrust collar is then rotated to transfer the blue dye from the collar to the faces of the shoes. Then the thrust collar is lifted away to see what kind of contact has been made. In this case, he finds that none of the bearing surfaces have been damaged, but the bearing surface of one shoe has some high spots on it. The fourth shoe in this ring has not made complete contact, so the bearing surface has to be scraped, in the same way we saw earlier in this module. When doing this scraping work, it's very important to work carefully. The secret to success is working slowly and gently, so that not too much material is removed at one time. If too much material is removed, the bearing shoe can be ruined, so the worker uses a light touch to scrape away only enough bearing material to remove that blue dye compound. He has left the blue dye